Hi, today we're going to talk about dilutions when we're discussing solutions. Make sure you realize that dilution does not mean weak. When we talk about weak and strong, we're talking more about acids. In this case, we're talking about concentrated and diluted. For example, you can have a concentrated 12.0 molar hydrochloric acid solution, or you could have a diluted one of 3.0 molar HCl. So, when we look at dilutions, we're talking about solutions that can be diluted by mixing in more of the solvent. And when we talk about the solvent, in most cases, again, we're talking about water. For example, if I want to dilute this 12 molar HCl into 3 molar HCl, I have the same amount of solute, the HCl, I'm just going to add more of the solvent, in this case, water. So here's our formula. M1V1 equals M2V2. So this is one solution, and this would be our second solution. It doesn't matter which way you write it. So M stands for the molarity, V stands for the volume. You just have to make sure that your volumes are in the same units. What we tend to do is, since molarity is moles over liters, remember, molarity equals moles over liters of solution. We usually change our units to liters for volume. But if they're both in milliliters, you can actually leave it in milliliters. So let's look at a problem. How many liters of 18.0 molar H2SO4, this is sulfuric acid, are required to prepare 1.00 liters of a 0.900 molar solution? Students ask all the time, how do I know which are my ones and which are my twos? I tend to look at the word of a, two different words. Whatever is sandwiched on the outside of a, these go together. So you can either make these ones or you can make them twos. So I'm going to make this a V1 and I'm going to make this an M1. So my other molarity is going to be my M2. The liters that I'm trying to find is going to be my V2. You've got to make sure you have the right ones together. So in this case, M1 is 0.900 M times my V1, which is 1.00 liters, equals my M2, 18.0 molar, times my V2. You're solving for V2, so you have to isolate it. Using algebra, we're going to divide both sides by our 18.0 M. Divide both sides, 18.0 M. These will cancel out. We'll be left with our V2, 0.900 M times 1.00 liters, divided by the 18. You should get, if you do it right, 0.05. Going back to look at how many significant figures, 3 significant figures, 0, 0 liters as our final answer. Okay? That's the first problem. In this case, we're solving for a volume. The only other thing you can solve for is molarity. So let's look at this problem. If you dilute 20.0 milliliters of a 3.5 molar solution to make 100 milliliters of the solution, what is the molarity of the dilute solution? Again, we have the two words, of a. I would put a box around them, circle them, underline it. So we know that this is our volume. I'm going to call that volume 1. This is going to be my molarity 1. They're together. Milliliters, again a volume, so I'm going to put volume 2. Notice milliliters and milliliters. You can either convert them both to liters or leave it like that. Technically you should convert it, but it'll work out the same way. And this is going to be my M2. This is what I'm trying to find. Set up your problem again. 3.5 molar times 20.0 milliliters equals M2, that's what we're looking for, times what's given to us in the problem, 100.0 milliliters. Again, isolate M2 by itself. So I'm going to divide both sides by 100 milliliters. 100 milliliters. And the reason I say you don't have to convert it to liters, because we know milliliters is going to cancel out. So 3.5 times 20 divided by 100, you should get an answer of 0.70 molar. And I'm just going to have two significant figures because of the 3.5 given in the problem. And that's your final answer. Just make sure that you identify which two go together. Again, it's usually separated by the two words of A. And then solve the problem.